you can add to the column A of all the rows. Colon without anything else just tells you all the rows. Comma, now if I have a fourth column, we don't have a fourth column yet. I can make a fourth column. Let's see, 7, 8, 9. That's a good one. 7, colon, 8, colon, 9. There we go. So we can add to matrices. We can take subsets of matrices, pieces of matrices, and things like that using this kind of notation. Okay, make matrices bigger, and so forth. We can delete a column or a row. Let's delete. Let's say we just added this last row. Let's go ahead and delete it. This means basically 2 brackets without anything else is a null. It means get rid of it. Not only don't put zeros in it, but get rid of it completely. If I wanted to put zeros in, I would do 0, colon, 0, colon, 0. But I don't even want zeros. I want it not to exist. Let's take a look up here. A is the matrix we're working with. It says it's a 3 by 4. If I do this, it should turn back into a 3 by 3. Voila. And it does turn, by the way, if it can list all the elements, it will. And it is a 3 by 3. Up here in the workspace. If it can list all the elements, it will. Okay, so that's adding columns. Adding rows is really similar. So you can work with matrices and stuff like that. Identity matrix. That just puts ones down the diagonal. You've already seen ones. We also have zeros if we want to create a matrix of nothing but zeros. This is a 2 by 2 matrix of zeros. You can go a 2 by 3 matrix of zeros if you put how many rows, how many columns. So if you have a square matrix, you can just use this. If you have a rectangular matrix, you can specify number of rows, number of columns. And you can even go deeper. You can keep going in dimensions if you want to. Okay. See, zeros, ones, we've seen, okay, random, that's a good one to talk about. Oops. Rand. This will create a random, uniformly distributed random numbers from 0 to 1. Rand n is normalized distribution, so this is centered at 0, mean is 0, standard deviation of 1. For rand n, rand normal, random number generator, normally distributed. Rand without anything else is just uniformly distributed. You can make a random number matrix of 3 rows and 4 columns. Okay, so those are just some ways to generate matrices. I wanted to, let's see, what do we have up here? We have B and BP. I can do, oops, let's go back here. Now I'm going to do this element by element, B dot star BP. This will just take the first, I don't think it'll work, to tell you the truth. It doesn't agree. Because they both have to be rows or they both have to be columns. So let's try this. And it does work. So it takes the first element of B times the first element of BP. So 5 times 5 is 25. 6 times 6 is 36. So this is just, we just create a vector, dot star itself. If we do that, we're going to get 10 elements. You're just going to get the sum of squares between 0 and 10. There are easier ways to do this, but this demonstrates how the dot works. If I do this, one is transposed and the other not, it doesn't work. Doesn't work. But if they're both transposed, it will work. But now this time, we should have a column this time, not a row. Without the dot, the first one has to be a row vector, and the second one a column. Works. And it works differently. If this is the sum, let's try that. Sum is a function you can do. Oops, I don't want to do that. I want to go back to here, and I want to take the sum of this. Sum is a function in MATLAB that just adds everything up. This should equal 385. Without the sum, we just get a list of numbers. With the sum, we get 385, which is the same as the row vector, where's the row vector, times the column vector. Column times a row ought to work the same way, by the way, or it shouldn't work the same way. I think there will be a mismatch in this case. Am I right? Wrong. I'm trying to think. So the second one's a row vector, the first one's a column, so it should make, I know what it'll do, it'll make a 10 by 10. So it takes the first, so they behave differently. Row first, let's see, there's row first and then column, you just get a number. That's your dot product, by the way. The dot product you guys do in vectors, this is the dot product. Row times column, dot product. This is something we don't encounter in physics. It's called the outer product. I take that back. Is this the dot product? This is the dot product, excuse me. Vector 1 times vector 2. This is the dot product. This is element by element multiplication. First element of one times the first element of the other. Second element times second, third times third, and so forth. Dot product, row vector times column vector. Outer product, column vector times row vector. And so that ought to give you some handle on how this dot thing works. The dot in front of an operator just means element by element. Do everything element by element. Powers, you got to do that way too. Let's go A. If I take the square of vector A, I'm going to do B. A will work, B won't. It doesn't like it, but if you do it element by element, you can do it. Okay. Let's see. Oh. We can do some things like, let's go, AP is 1, 3, 2, 4. Let's go back to A equals 1, 2, colon, 3, 4. So this is relational operators. Now we can test for equality, greater than, less than, stuff like that. And let's go AP. There we go, AP. So we've got two matrices. The diagonals are equal, but off the diagonal they're not. A equal, equal. Now we use a double equal sign to test. Single equal sign, set. You're setting one thing, you're setting what's on the right, you're setting what's on the left equal to what's on the right if you use a single equal sign. Double equal sign, you're testing if they're equal. It won't change either one. And if we look up here, here's A and here's AP. It won't, when I execute this, it won't change either one, but it'll give me a new answer. Where they're equal, you get a 1. Where they're not equal, what elements are not equal to each other, you get a 0, just like we expect. You can also do A greater than AP. So what elements are greater? And there's only one. That's down at the bottom left. What elements are less? Oops. Only one, upper right. What elements are greater than or equal to? It should be 3 in the bottom left. And what elements are less than or equal to? 3 in the upper right. 3 elements in the upper right. You can set this equal to equals A less than equal to AP. Okay, so now we're setting this new variable equal to the result of this operation. And I'm pretty sure we can put it, if you guys like, you can do it with or without parentheses. For readability, you might like parentheses. So we'll get this. But you can do it without parentheses if you want. Sometimes humans like parentheses because it's easier to read. Let's see, we've done, oh yeah. We can also do the not, which is the squiggly, which is the squiggle. Oh, this is not, by the way, I just messed up. I forgot, I wanted to take the result and negate the result. It didn't do that. It negated matrix A first. So whenever A was 1, it turned it into a 0. It negated that first, and then it did less than or equal to. So if I do not, there, this is what I wanted. It should be just the opposite of this. So not parentheses. When I did it before, this one up here, the computer did this part first, and then it took this result and did the rest of it. So I got a much different result. Okay, you can do and ors and stuff. A less than AP. Or is a vertical line. It's the vertical underneath the backspace shift. The shift / keystroke. And so you get a vertical line that looks like that. So if it's either one, if A is less than AP or A is greater than AP, then it'll give me an answer. This is the or. What do you expect? See, A is number 3 is in the second row, first column of A, and 2 is in the second row, first column of AP. So A is only going to be, A is greater than AP, bottom left. It's less than AP, upper right. It's equal everywhere else. So if I do the, well, anyway, this ought to be all ones. Or, no, excuse me, it's not all ones. Where they're equal, you'll get zeros. So it ought to be 0 down the diagonal, 1s at the corners. Okay, and let's do the and one. This should result in all zeros because either it's less or it's greater. It's never, anyway, all zeros.